afternoon and welcome to the fourth concurrent session of the day, Rguroo, introducing a web-based statistical software for teaching your statistics course. Our presenter today is Dr. Jamshidian from California State University, Fullerton. Dr. Jamshidian is a CNSM Distinguished Professor in the Mathematics Department at California State University, Fullerton. He serves as a graduate advisor for the Masters of Science in Statistics at CSU. His past positions include Associate Professor of Statistics at the University of Central Florida and Senior Statistician at the BMDP Statistical Software. His research area is broadly in computational statistics with publications in major theoretical and applied journals such as the Journal of the American Statistical Association, Journal of the Royal Statistical Society, and Psychomatica. He is currently an associate editor for the Journal of Computational and Graphical Statistics. In the past, he has served as associate editor for the American Statistician, Journal of Statistical Software, and Journal of Statistical Computation and Simulation. His current activities include research in statistics education and the development of statistical software for teaching statistics. If you have any questions for the presenter during the session, please feel free to enter those into the Q&A section at the bottom of the Zoom room screen, and we will address them at the end of the talk. On that note, I will hand it over to our presenter.
Thank you, Julia. And thanks everyone for attending. Today, as you know, I'm going to be, so let me just make sure that I'm sharing screen here. So let me just go ahead and share my screen. There we go. So I'm going to be introducing Rguroo, which is a web-based statistical software. And I will tell you the story at the beginning of how Rguroo came about. Then I will show you a quick demo of Rguroo to give you a feel for how things go in Rguroo. And then I make a few final remarks. So with that, let me tell you about this story. About 2010, I became the coordinator for our introductory stats course at Cal State Fullerton, where I teach. And at that time, there was no software was used. And I believe that if we are teaching statistics, especially in this day and age, we must use software. So I began using R, and so we had some difficulties that we had to that we had to deal with. One was that when you're using R, you need to do coding, and I was aware that students might have difficulty actually writing codes, especially in introductory stats courses. Also, some of our faculty who were teaching the course were not familiar with R. So a colleague of mine and I just wrote a manuscript that was published, in fact, by Cengage, where we described how you do linear regression or how you do a histogram in R. It turned out that that didn't solve the issue because our students still were not able to write code in the sense that they would make mistakes in syntax. Oh, they forgot to capitalize, they forgot a comma, etc. So our time was spent a lot on correcting syntax rather than teaching statistics. Then came a turning point. It happened that I was in a gathering of friends, and a friend of mine who is a great software engineer approached me and said, "Hey, do you think there is a project that we can do together?" And after thinking for a second, I said, well, listen, there's this R, which is a powerful statistical language, but our students are having a lot of difficulty with it. And can we put a graphical user face on top of it? And so, he said yes. And that's how everything began. That conversation took place in 2014. And here we are today with Rguroo being used in many universities and colleges for their stats courses. So main goals in developing Rguroo was to develop a software that helps instructors to teach their statistics courses using modern methods. Of course, we also support classical methods. Also to provide a software that relieves students from computing drudgery and allows them to focus on learning statistical concepts. And this is in line with GAZE. GAZE stands for Guidelines for Assessment and Instruction for Statistics Education, that is published by American Statistical Association. And I think it's a great document to read by those who teach, especially introductory stats courses. So, so with that, I'm going to start giving you a tour of Rguroo. So this is the website for Rguroo. Let me just maximize the page here. Rguroo.com is where you can access this page. What you see here is various information about Rguroo. In particular, there's a resources page that has lab book related material, video tutorials, user's guide, a few other webinars that I have given, etc. And for example, in the lab book related lab and book resources, you see Hawkes textbooks, for example. And here for Hawkes textbooks, let's say you want to do a linear regression or regression, I'm going to just say, you just type in a keyword here, and then you get a link to how you can actually, for example, do multiple regression in Rguroo. So this is a very short thing that is shown here, and it shows output, etc. And so you can quickly get started with Rguroo. And there is a link here to the user's guide, and even here, if you just click here, you get a video that you can watch to see how you could do, for example, simple and multiple regression. All of the videos in Rguroo have a copy link that you can use in order, if you wanted to put it on your learning management system or share it with students so they can watch a video on their own. All right, so with that now, let me just continue with the website. There is the support page where you can contact support. There is email support available. And as I said, the more information there is the register site where faculty can obviously get accounts for free. Whether you adopt the software or not, all faculty get their accounts for free. And students can register here as well. Finally, I can just go ahead and log into Rguroo. So Rguroo is a web-based software. That means you don't need any downloads or installations. All you need is an Rguroo account, and you just need to log in. In fact, no plugin is either needed for using Rguroo. So I'm going to go ahead and log into my account. And once I log in, you see this is the Rguroo environment. So the environment is divided into, on the left part, data, plots, analytics, probability simulation, and applets. And I will use the analytics and probability simulation today in this talk. And then on the top, you have video tutorials where, for example, again, you could just search for topics. Let's say if I say confidence interval, then you get various confidence interval videos. You just double click on it, and students or you can just watch a video and see how, for example, you can compute confidence interval. This one is for two population proportion, etc. And by the way, all of the videos are closed captions, and the software is completely accessible. So what you see here is a user's guide. This is a comprehensive user's guide that has technical material in it, examples in it, and it's quite extensive. There is the dashboard that is not yet available to everybody, but it will be available soon. In this dashboard, what you will be able to do is you will be able to form classes or create classes and create your own data repositories. And I will tell you what data repositories are, or private data repositories, and share with your students. So let me just go ahead and open up the data part here. So in the data part, we have data import, where you can import data sets, obviously. So you can import data sets. Let me just begin, in fact, importing a large data set. This is marriage data set. This has a large number of cases I'll show you in a minute, but here I want to show you that you can actually import data from, so let me just say upload here for a second. So you can import data from various formats: Excel, SAS, CSV, SPSS, Stata, RData, whatever, right? So what you can see here, it took only a few seconds to upload the data marriage. It has, in fact, 17,568 rows. Notice that the data gets divided into numerical variables and categorical variables, and for each categorical variables, you see levels, etc. And here is the data set itself. So you can see that it has 17,568 rows and 31 columns. And now this data set is available throughout the, the software. So I won't be working with this particular data set today. I just wanted to show you how you can import a data set. Now, another thing is that we have a data set repository that has over 3,000 publicly available data sets. In particular, and also for various textbooks. So in particular for Hawks textbooks, if I just, excuse me, if I just type in Hawks here, you see these are the data sets for discovering statistics and data. And then if I do beginning statistics, these are the data sets for the beginning statistics books by Hawk. And here, for example, if you just click on information, you get information on each of the data sets. What is nice about these data repositories is that you can just click on a data set. Let's say this is Amazon stock price. It has 5,121 rows and 7 columns. And students can simply import them. And so they don't have to go anywhere. All the data that is related to their book is available. And the data set becomes available here. And for example, you could right click on it and see the data summary, etc. Okay, so that is the data repository. And as I said, in the future, you are going to be able to have private data repositories. You could create your own data sets here. I'll talk about RGR files a little bit later. Notice that everything can be organized in folders and subfolders. And so you could have an organization of your data right here. Then you have the plot section, and various plots are there: bar plots, box plot, bubble plots, etc. I won't be using the plots too much today, but I have given previous webinars, Hawks webinars, that are actually, the links are on our website under video, under webinars. If you go under resources, and you'll see how we can actually do plots. There's a lot of customization you can do with plots, and also it is the GUIs, or graphical user interfaces, are fairly intuitive and easy to use. All right, the next thing is analytics. You see various things like proportion inference 1 and 2 populations, mean inference 1 and 2 populations, ANOVA, regression, etc. These are organized like book chapters and topics in a book, so it's easy for students to figure out where they need to go when they need to do an analysis. We have probability and simulation. In the probability simulation, we have probability calculators for both continuous and discrete random variables. Many random variables are included: normal, chi-squared, F, etc. In discrete, binomial, Bernoulli, Poisson, all of those, in fact, many, many more. Any kind of random variable that is available in R, which is quite extensive, is available in these probability calculators. You have random generator for random number generation, and multiple distribution random generator, which is a more sophisticated version of random generator. And then you have random selection, which I will use today also in my demo, where we can select randomly from a data set, for example, to generate from a specific population, or even do bootstrap if you want to do bootstrap type stuff. All right. Finally, we have the applets, and all the Rossmann chance applets are here, which are nice for doing animations and showing statistical concepts by animations. Calculators, Desmos calculators are available here. And notice that everything opens up within the application. It is not a different tab in the browser. So you are within the application, and it's easy to maneuver when you are teaching. All right, so let me just go ahead and now begin my demo of a problem. So let me begin with a plot that I have already done in Rguroo. It's called California Vaccinated. So the Kaiser Family Foundation had some data on the percentage of people in different states that were vaccinated by February 16, 2021. And so I chose California because it is one of the most diverse states that we have. And just for your information here, California has 40% Hispanic, 36% white, 15% Asian, 5% Black, and 7% and 4% other ethnicities in their population. And by February 16th, these were the percentages that were vaccinated. 18% of the Hispanics were vaccinated, 36% of the whites, 14% of the Asians, and 3% of Blacks, and 1% of the other. So now, using this data, what I want to do is, suppose that I want to talk about teaching sampling variation here, okay? So what I do is I'm going to say, all right, let's just focus on the percentage of Hispanic in California. Let me just keep this, that were vaccinated. It's 18%, right? Now, so then I asked my students, suppose that on February 16th, I went and took a random sample of 100 Hispanics, and I asked them, have you been vaccinated or not? How many do you expect in my sample to say they have been vaccinated? Well, if there are 100, I think students probably can guess that it would be 18. Then I say, well, if I take if I take different samples, would I get 18 all the time? And probably they can guess no. What about if I take a sample of size 10? Well, 1.8, well, 1.8 doesn't make sense, maybe then 2, 3, etc. But then the question is, how is the variability? How do these samples vary from, how do the proportions vary from one sample to another sample? And so that idea of sampling variability, we can teach them using simulation here. And of course, I'm going to go a little bit faster for you because you're faculty, you understand the concept, but I'm trying to show you the tools that are available to you. So let me just go ahead and now start my simulation. So first of all, I have here prepared a data set, which is California Hispanic vaccinated. This data set says 18% yes, vaccinated yes, 82% vaccinated no, right? And what I want to do is I want to sample from this population, right? So for example, some of you guys have done probably flipping of coins simulation in your classes. And so for example, you could do flipping of coins here, heads or tail with percentages that you want. All right, so how do we sample from this population? Well, so I'm going to go ahead and open my probability simulation and choose the random selection function here, okay? And let me just go ahead and close this right window here. What I'm going to do is I'm going to put this on this side here, and I'm going to pin this so when I run things, it doesn't go away. I'm going to select my data set, which is California Hispanic, and let's just take a sample of size 10 here, let's say. And what I would want you to notice is that I want to take a sample of size 10 from this column, which is column 1 of my data with these probabilities. So I'm going to say the probabilities are given by the column labeled percentage, and I want to take a sample from column 1. All right, so let's just go ahead and do that. So when I do that, I got a sample of size 10, and remember the population, 18% in the population are vaccinated, and in my sample of size 10, nobody is vaccinated, right? I can briefly explain the idea of seed, that if I just change the seed, I get probably a different sample, right? In this case, again, I got the same sample, but let's say I just try another one, 224, let's say, or something like that. And now you can see that, for example, in this one, I got 2 yeses, right? So first of all, in terms of teaching, I must say that this seed is useful because, when I'm assigning homework, I want them to use the same seed in order for me to know what the answers are that they would get. So we are all uniform in our answers. Now, of course, if I want to repeat samples, it doesn't make sense for me to change seeds every time. So what I can do is I can just say, let's replicate, let's say 2 times. So I'm going to get now 2 samples. It says sample 1 and sample 2. In fact, let me just go ahead and group this by, so you can see the samples separately. So this is sample 1 that has 10 elements in it and nobody is vaccinated. And then this is sample 2 that has, again, 10 people in it and only 1 person is vaccinated, right? Okay, but now what I'm interested in is the proportion of vaccinated within each sample. How do I compute that? Well, we know that the sample proportion is a statistic, right? Okay, now, so I'm going to just go ahead and call it p hat 10. I'm going to call it 10 because it's based on a sample of size 10. And now here, I can write general R code to come up with this sample proportion. Now, I could really write this all in one line, but I'm going to write a more sophisticated one right now. So I want, in order to compute the sample proportion, and I'm interested in sample proportion of yeses, right? So what I need to do is I need to count the number of yeses and divide by the total number of cases. So the total number of cases, I'm going to say n, is the length of the variable vaccinated. So this is applied to each sample. The length of each sample is 10, so n is going to be the sample size, right? Now, how can I count the number of yeses? I can write a little code. So let's say number of yeses is equal to, we are going to say sum the vaccinated values that are equal to yes. Okay, so what this does is vaccinated equal yes, it's 0 if it is no, it is 1 if it is yes, and we add all of the yeses. Okay. All right. Then my p hat is going to be number of yeses, right, divided by n. Okay. All right. Now, whatever I write in the last line essentially gets assigned to this variable here. Okay. So let me just keep this for a second. And I'm going to say go. I now notice instead of the samples themselves, I'm getting the proportions. So in fact, let me just ungroup these. So remember, for the first sample, we had no yeses. And for the next sample, we had 1 yes, right? Okay. Now let's see it a little bit more. Now to see the sampling variation a little bit more, I'm going to go ahead and say replicate 100 times. Okay. So I'm going to replicate 100 times, and what I'm getting now is 100 different sample proportions. What I'm going to do is I'm going to save this. So let me say simulation with n is 10, and I have replicated it 100 times. And I'm going to tell you what the difference between these 2 saves are. So let me just go ahead and copy paste it here. Now, when I just click, let me start with this simpler one. When I click this save right here, then notice that says dataset sim n10 r100 got saved. So you get your dataset saved as an independent dataset. When I do click on this save, then all of the parameters here get saved. And essentially, if I log back in or close this and log off, log back in, close my window, whatever I do, when I come back, everything that I have done is actually available to me, and I can continue working with it. This is particularly important because we can share these things with students, what we have done with students, using RGR files, which I'll explain later. Okay, so now that I have my data set, let's just go take a look at it. All right, so I'm going to go to plots here, and I'm going to create a dot plot of this. All right, so the dot plot is going to be, I'm going to just choose my data set. It says p hat of 10. I'm going to select this p hat of 10, and I'm going to have it draw the dot plot for me. So here is a dot plot. Now, what is interesting here is that, remember, what we are trying to estimate is 0.18. Fortunately, most of our values are around 0.2. We know that we can't get 0.18, right? Because based on a sample size, 10.18 is not possible. But most of our values are around 0.2. But it's important for students to see that based on a sample of size 2, I also get something very weird too, like 0.7, right? 0.7 is far from 0.18, which is the true value. Not only that, the distribution of this also you can see is sort of skewed. The question is, well, if I want to see the real sampling distribution, perhaps I should do more than 100, right? So let's just go ahead and do more than 100 here. And let me just go ahead and go back to my simulation. And instead of 100, let's just replicate 10,000 times. Okay. All right. So let me just do that. Now, notice that I'm doing 10,000 samples of size 10, and I'm computing the proportion for each one. I got 10,000 values here, right? And let me just go ahead and just save the data set here. Yeah, let's just save it as N10, but I'm going to say replication 10,000 here, so I know which one it is. I just want to save the data set. And now let's go back and go to our dot plot and go ahead and use our new data set, which is with 10,000 replications, and do the dot plot. And now, of course, lots of dots. There are 10,000 dots here. And in particular, you see that even values of 0.5 and 0.6 and so on appear. And so this is this is really the sampling distribution based on a sample of size 10. So let's just call it, again, let's just save this data set. Sim, this is N10, replicated 10,000 times. Okay, so when I do that, again, I get my graph saved here, and you can actually export the data, save your image, into your local computer, copy image and paste to Word, whatever you need to do with this. Notice that our graphs have basic details and level editors. As I said in this talk, I won't have time to go through it, but in details, you can do a lot of customizations. Level editors deals with levels of categorical variables and manipulating different levels, etc. Okay, so now this is based on a sample of size 10. Now suppose I ask what happens if we increase our sample size and what happens to this sampling distribution. So let's go ahead and do that. What I'm going to do is I'm going to change my sample size to 100 now. And let's say just change the name of the statistics to p hat 100. All right, and I'm going to go ahead and do this simulation now. So now it's taking a sample. Oops, I made a mistake here. Sorry, guys. Let me just go ahead. I said sample size 1,000, which is, it still did it, which is, well, let's go with 1,000. Why not? Every time you took a sample of 1,000 and it computed the sample proportion. So this is going to be really focused, centered around 0.18, but let's see what happens here. All right, so let's say this is based on N 1,000. Let me just save the data set here. And I'm replicating 10,000. Okay. All right, so I saved that data set now. Now what I'm going to do is I'm going to also go ahead and plot the dot plot for this. So let's go to the dot plot here. I'm going to go to basics, and let me just change my data set to n equal to 1,000. And I'm going to do p hat. By the way, notice that how fast these simulations were done. Every time taking a sample of size 1,000, computing the mean, the proportion, and doing it 10,000 times, it takes only a few seconds. Okay, so now here we go. Well, based on a sample of 1,000, this is what we expect, a normal distribution, right? So let's say I'm going to just say N1,000 here and save this. Now, maybe you want to just do this and compare this side by side, right? Well, if you want to compare this side by side, there is some nice feature in Rguroo where you can actually log into Rguroo 2 times, but be careful. It's got to be in the same browser and in a different tab of the same browser. So let me just go ahead and sign in again. So I'm going to sign into my account. All right. So I signed in. Let me just close this one. Now I want to have side-by-side comparison, right? So I'm going to just pull this tab out, and I'm going to go ahead and, put two parts next to each other here. Let's just open these two. And remember, the plot that I had saved is going to be here, right? This is the plot that I had saved. And now, well, this is the 10,001. I want to put the 10 one here. And now here I can, for example, talk about the differences. Notice that with sample of 10,000, you're very the values are very much concentrated about 0.18. You have the normal distribution, which is the central limit theorem. But with the sample of size 10, you have, you have not skewed distribution, not normal. And for example, you can talk about these rules of thumb that we talk about, like n times p, which is, in this case, n is 10, and the probability of success is 0.18, which is gives you 1.8, and it's less than 10, for example. And in this case, of course, our n was very large, which was 1,000 and times 0.18, which gives you 0.18, which gives you 180, and it's bigger than 10, and so you see the normality. And so you could actually go ahead and discuss this kind of problem with them. So this is an example of a simulation and how you can show sampling distributions here. All right, so let me just go ahead now and get my browser back. Let me just go ahead. Some reason okay, there we go. So let me just go ahead and close this window for now, or minimize it. Yeah, let me just go ahead and close it. Maybe we can just continue with this. Hold on. Yeah, let's just continue with this window. All right. So now what we have is this. Let me just go back and let me make sure, by the way. Yeah. Let me go ahead and go back now. I want to do an inference problem, which is related to this problem for you guys. So let me just go ahead and open my PowerPoint here. Okay. So let's consider this test of hypothesis. Suppose that in a random sample of 100 California Hispanics that we take today, so taking a sample of size 100 of California Hispanics today, we find 20 who have been vaccinated. That is, our sample variance, sample proportion is 20%. Does this mean that there has been a significant increase in the proportion of Hispanics who have been vaccinated as compared to February 16th? Remember, in February 16th, 18% were vaccinated. So we are asking whether the population proportion is bigger than 18% if we get 20% in a sample of size 100. Okay, so this is an inference problem that I want to do using Rguroo. So this is about sample proportion. I'm going to go to analytics, and I'm going to just choose proportion inference, and I'm going to choose one population proportion. Again, I don't need this. Let me just go ahead, and it says, what is the factor? And for the factor, we are going to say vaccination status. Okay. And I need to spell this right. And a success is that somebody is vaccinated, and a failure is that somebody is not vaccinated. Now, by the way, you could enter a data set if you want. That would work too, but I'm just writing values here myself. Remember, my sample size was 100 and number of successes was 20. So if I am doing and I'm testing the hypothesis that P is bigger than 18%, right? Let's go with a simulation method first. Okay, so I'm going to just do a simulation method and just say preview. All right. So when I preview, I get a nice output. It has my data summary, which gives me the count of vaccinated versus not vaccinated, and the percentages. Here it says test of hypothesis, vaccination status, the method is simulation based, and it spells out what it is that I'm testing. Proportion of vaccinated is greater than 0.18, right? And it gives me sample size, number of successes, sample proportion, and then it gives me the p-value that we are all used to. It also gives you an index called Bayes factor bound. This was actually an index that was recommended by Benjamini and Berger in a paper in 2019 where they were discussing p-values in the American Statistical American Statistician Journal. And here I have, we have actually the interpretation of Bayes factor bound as well, right? And you get actually a nice graph where it says, okay, this is a p-value, so this is the proportion of vaccinated here, and so the proportion is probability of p hat bigger than or equal to 0.2, and there are 0.3394 is the p-value here. Maybe you want to show your students how the p-value is computed here, and you can do that. So let me just bring your attention to this report layout where you can actually customize your report any way you want. So what I want to do is I don't want to look at data summary anymore, and I don't want to look at the other table. I just want to look at the p-value, so I can do that. So let me just keep this here. And if you're trying to teach them how the p-value is computed, for example, you could go here, and instead of 10,000 replication, let's say you can do 100 replications, right? If you do 100 replications, then you kind of can count. There are 34 red dots, which are above your observed value, at or above the observed value. And then there's a total of 100 dots. And, you can explain how that p-value is computed. And of course, then to have more accuracy, what you want is you want to increase your replications to 10,000. And in that case, you just get, the complete, a better estimation of the sampling distribution and the p-value. All right. So let me just save this here. Let's say test. Let's say test prop or something like that. Now, when you, as I said, everything is savable here and retrievable. So let's keep that. Now, of course, a lot of you are using, classical methods. And we could, for example, just say, let's just use the large sample Z here. And so if you do that, then you get the usual ordinary large sample Z, where you have now your table, critical values, p-value, etc., right? And again, I can just show you in the report layout, it shows that there are just two tables here, right? And if you're, for example, teaching based on, let's say, critical regions, then you could also do that. If you go just to the advanced features and choose test of hypothesis, you could say, well, just show me the critical region graph as well. And maybe you just want to show the critical region at the beginning of the report. And so here you go. So here is the critical region for 5% test, and then this is your observed values, therefore you don't reject. In all of these, you can export all of the reports into Word or HTML, standalone HTML. In fact, what you get is even a separate graph for each of the graphs that are in the report. You do get a separate file when you export them. All right, now with that, let me just go ahead and talk about a few things here. For example, right here, I have my data. Notice that some of the data sets, so let me just go ahead and close some of these. Maybe you can just call this test prop 1 or something and save that as well.
I apologize for interrupting, but I just wanted to let you know we only have a few minutes left, and I want to make sure that you have time for question and answers.
So yeah, I'm wrapping up. Okay. All right. So let me just say that some of the you can see that some of these are bold-faced. So if you just look here and open this, right-click on it, you can see show dependency. So it says, for example, what have you done with this? with these California Hispanics, remember we did a simulation. You can just go back and open it, and it just opens exactly where you were. It's already open. That's why it didn't do it. It just here, if it was not open, then it would just go ahead and open it. That's one thing. Another thing that I want to mention is that whatever you have here can be actually exported as RGR files. So what you can do is you can export as RGR, okay? And then this will get saved, wherever you wish to save it. And then you can import or share these RGR files with your students so that they can see exactly what you have done. So with that, I guess I'm just going to have a few final remarks here to wrap things up. So we have paid close attention to GAI's technology guidelines, ability to import data in multiple formats, as I showed you, text files, SPSS, Excel, etc. Interactive capabilities and dynamic linking between data and graphical and numerical analyses. Again, I did not show that in this webinar, but you can watch our webinars on data visualization. You can, as I said, export RGR or export our Word files, export into Word files. There's consistency across platforms because the software runs on any browser. In fact, you can also run it on tablets. The software is fully accessible to disabled. And here is a final quote that I would like to talk about. It is by Brian Ripley, who is a very famous statistician. It says, "Let's not kid ourselves. The most widely used software for statistics is Excel. This is surely true, but it is equally true that only a tiny minority of statisticians have a degree in statistics. We have to distinguish between a statistical software and the much wider terrain of software for statistics." Notice that he calls Excel software for statistics and not a statistical software. So we can have a lengthy discussion of differences between software for statistics and statistical software, but let me give you a brief explanation. Can you fit a linear regression model in Excel? The answer is yes, but do you get an output that includes all the diagnostics, etc.? Probably not. Can you do graphs? Yes, but can you interact with graphs and dynamically check, for example, outliers, etc.? Probably not easy to do with Excel. So statistical software provides our students with a comprehensive set of tools so they can carry out the statistical investigations all in one place and not to perform statistical tasks in isolation. With that, and of course, Rguroo is a statistical software, an online statistical software. With that, I'd like to thank you for your attention, and I'll give it back to Julia.
Thank you, Dr. Jamshidian. And we did have a comment that came in. It's not a question, but we did have a professor say that this is really cool, and she thanks you for this presentation as well. One question that I had for the software is if a student is working on a graph and they need to compare it to another, is there a way for them to just basically do like an overlay and lay them on top of each other to compare those values?
Yes.
Is that possible?
Yes, that is. So what you can do is, in fact, I didn't have time to do this. Suppose that I had these two, these two graphs. One was based on a sample of size 10, and one was based on a sample of size 100, right? And in that case, let me just stop sharing here. So what I could do is I could merge them, for example. We have a merge function that you say, okay, merge them, and then you could graph both of them on the same panel, and they would just show up like from top to bottom. Yeah, there are many ways to do that. One way is, as I showed you, is to actually go ahead and show them in two different browsers. But yes, you can also do them in the same graph. Yes.
And also, once they do that, I myself am not that familiar with statistical software, but if they do the overlay, can they export it that way? Will it also show up in Excel that way? Because I'm not familiar with using Excel with those tables either.
Yeah, so of course you can export. All you do is you right click on the image that is there, and you can copy it and paste it, for example, to Word, to PowerPoint, or even you can download it to your local computer, and then upload it to whatever software you are using. In fact, not only that, the default for our graphs are PNG files, if you are familiar with them, but you could come up with like SVG files, bitmap files, all of that. For example, SVG is very nice because it gives you high resolution and a nice graph. I should also mention that we have also integration with Canvas. So if your school is using Canvas, we can actually integrate our Rguroo as a tool to Canvas. So students essentially just log in to their account without actually putting in their username and password directly, and they just go directly to our Rguroo. Yeah, and by the way, our Rguroo is bundled with Hawks textbooks, and so you can bundle them with various Hawks textbooks as well. Sorry, Julia, I think you are muted.
Right. Yeah, there we go. We have a couple other questions. This is an awesome undertaking and looks very thorough. How much coding would one still need to do to use our Rguroo on average?
I would say on average 0. What I showed you what I showed you was I specifically showed that part which required coding. In fact, what I did with coding, you could go and do random generation, and those proportions that I did, you could just, for example, generate from Bernoulli and just say, give me the proportion, and it will be right there. So you don't have to even write code for that. So what I did with code is possible without code. So I would say you need zero coding actually to use the software. It's just that I wanted to showcase how actually R can be used within the software as well.
Thank you for that. And we also have one last question. How long can students continue to use your stat software after purchasing your software?
So that's a good question. So we have 2 different types of license that are sold. One is based on 6 months, and one's based on yearly subscription. So if they buy the 6 months, and of course it can be bundled by Hawks, but the 6 months is like $11.99, I think, and the 1 year is $19.99. So if they buy the one year, they can use the license from the day that they establish their account until 1 year they can use it, and of course they can always renew their account at any point. Yeah. So it's six months or 1 year. Usually a semester is 4.5 months, so they can still continue using it.
Well, thank you so much. It looks like we're out of time, and thank you, Dr. Mori, for taking the time to share this valuable information with us today. I'm going to launch a quick 3-question poll on the presentation that we just watched. So please take a minute to send us your feedback. During this time, you can also join the next concurrent session, which will begin at 4 p.m. Eastern. You can view the chat session for those meeting room links, as well as access the conference website for a complete list of concurrent sessions and their descriptions. While accessing the conference website, don't forget to swing by the exhibit hall to talk with the Hawks representative one-on-one. Thank you for attending.
Thank you, everybody, for attending as well, from my part.